In example 4, we are going to find the function g compose f of x and its domain, given that f of x equals the square root of x and g of x equals the square root of 4 minus x. So it's important to see here that although f of x and g of x are the same functions we used in example 3, now we're computing g compose f of x rather than f compose g of x. And these are not the same things. G compose f of x is g as a function of f of x, and f compose g of x equals f of g of x. So, really what we're doing is we're putting f of x in for x in g of x now, rather than g of x in for x in f of x like we did in the last example. So we're going to start off by finding f of x here. We're going to write down f of x because this is what we want right here. We're going to use this statement. So we start off with f of x equals the square root of x. Now, we need to sub this in for x everywhere x exists in g of x. So I'm going to get g compose f of x equals the square root of 4 minus, and instead of writing x, I'm going to write f of x, which is just the square root of x. Yeah. So we have our function. Now we need to find its domain. And we know that you can only take the square root of a number which is greater than or equal to 0. And now you can see that we have two square roots we have to take into consideration. We have this root x, and we also have the root of 4 minus root x. So there's two different restrictions that we have to be wary of here. The first one, I'm going to look at x to the half, or just the root x part. And we know that you can only take the square root of a positive or 0 number. Therefore, x must be greater than or equal to 0. So that one was simple enough. The second one's a little more complicated. The second one says that 4 minus root x must be greater than or equal to 0. So let's solve for x in this case. Move the 4 to the other side. We get negative root x must be greater than or equal to negative 4. Let's multiply both sides by negative 1. And in doing so, we will flip the inequality. So we get that the root x must be less than or equal to 4. Squaring both sides, we get x must be less than or equal to 16. So now we have to take these two restrictions into consideration and find where they both agree. So let's draw this onto a number line. If this line represents x and this is x equals 0, our first interval or restriction I will write in green. This one says that x can start at 0 and it can continue to increase, and it can exist anywhere approaching infinity. Our second interval I will do in red. The second interval says x must be less than or equal to 16. So let's say that this is 16. It can start right on 16, and it can go all the way approaching negative infinity. So you can see how there's a common area which incorporates both of these intervals. And that would be from including 0 all the way to including 16. This is the only interval which will allow our g compose f of x function to exist. Therefore, our domain can be written as such. X is such that x is between 0 and 16 inclusive. And inside this interval, x can exist in the set of all real numbers.